Hello, everybody. Thank you very much for attending the Red River Apiarist Association February 2022 meeting. And we're going to move right on to our esteemed speaker, Etienne Tardif, who is joining us from north of 60 from the Yukon. He's one of the Northern Canadian premier beekeepers, and he's here to talk to us about the principles of good beekeeping and the thermodynamics of the hive. This meeting is being recorded, and I want to give a special thanks out to Ian Stepler and the Manitoba Beekeepers Association for arranging Etienne to speak with us tonight. So as to introduction, Etienne has his roots from central Ontario. He started his beekeeping endeavors in a mine reclamation project, and with a friend and fellow geologist, no experience, and a copy of Beekeeping for Dummies, their beekeeping journey was well on its way. He ended up settling in the Yukon territory as a consultant to the diamond industry, but in the summer, beekeeping, raising chickens, and large gardens with his wife was his primary passion. Over the last 8 years, he's kept bees north of 60, where he's adopted a very data-driven approach to beekeeping, which has helped him understand the bloom calendar, the annual bee cycle of that territory, and that has led to him writing articles for the BC Bee Scene newsletter and the American Bee Journal as well. He's also presented at Appomonia with his Yukon beekeeping approach. He's run a 2-day introduction to beekeeping for Northern Beekeeping. He also uses those data sets to identify nosema infections, pollen sources, and to analyze his honey. And he's currently investigating a possible connection between nosema and amoeba disease in relation to increased winter bee mortality. He's passionate about and loves everything to do about bees, native pollinators, and continuously seeks to expand Northern best practice beekeeping. His current focus is winter thermal regulation, bee nutrition, and bee health. And his data and research has earned him funding from CAP in 2021. There is a lot of documentation and a lot of charts and a lot of other slides in this presentation, which will be available upon request. You can email the Red River Apiarist Association for a link to those charts and data sets. So please feel free to do so. And there's a lot of material to cover. So without any further ado, I'd like to present Principles of Good Beekeeping and the Thermodynamics of the Hive with Etienne Tardif. And thank you very much for attending.
Thanks for the opportunity. It's always a pleasure sharing anything about beekeeping. So it's I'll keep it to about 45 minutes, and then we can do questions. And if I can't answer everything, I'm always happy answering emails and going that route. So I'm just going to move this little box. So yeah, today I'm going to cover, it'll be probably at an intermediate level, but you'll see there's a lot of charts, but I'll speak to the chart and I'll introduce the concepts. There's some slides I'm just going to skip over. I'll quickly introduce it. It's just to show you what can be done with some of the data that I guess is a lot easier to collect nowadays than with the technology and things that we do. But there's some basic monitoring that we need to do with our hands, our eyes, our ears, the smell. So there's a lot of basics we can do that doesn't require any technology. So I'm just going to change my pointer to a laser pointer. So again, my goal is not to convince anybody about doing it one way or another. It's more about, for me, to understand how things happen and why things happen. And I like, especially if it's unknown, I like making theories, hypotheses, and then trying to prove or disprove what I'm thinking. So for those who've never been in the Yukon, so this is one of my bee yards just over here in this meadow. There's a swamp here. It's a mix of spruce, pine, and some willows and aspen. We do keep gardens. I got some chickens here. These used to be, I guess, a musher used to live here, a dog musher, but we converted the compounds into gardens and a chicken holding area. But yeah, so this is my backyard. Again, my background is engineering, but I do a lot of process improvement work. I also do reliability analysis. So those things come in handy because I'm used to using a lot of data, looking at the data, and then coming up with some reasons why things happen or why things didn't go the way we hoped to. So when I look at winter, I like it's about intensity of winter because most places in Canada will get a -30, a -40 occasionally, so which is fine. But the bees really it's how much cold. So how intense is your cold? So I just call them cluster degree days. But for people that are into HVAC or building houses, they call them heating degree days. So it's just seeing how much energy units the different locations across Canada and the US need. And then just to put things in perspective, I put some of the beekeepers that I guess tend to have a following on my chart just to do comparatives. Okay, so there's a couple beekeepers up in Dawson City. It's actually colder than Fairbanks. And he's quite successful. So it's actually a Kiwi beekeeper. He mines gold in the summer, and he does bees, and then he goes back to New Zealand and does bees there in our winter. So interesting fella, and so he sees beekeeping on two continents. So what I wanted to do here is just compare, just using this park data. So I just picked Winnipeg versus Watson Lake. The reason I picked Watson Lake is even though I'm about 40 kilometers from Whitehorse, Whitehorse is actually in a microclimate and it's actually warmer than most places in the Yukon. My evenings are about 10 degrees, 5 to 10 degrees cooler than there, so it's more like Watson Lake. But you can see from a growing degree days, we get about half to even less than half of a growing season that Winnipeg gets. And this growing degree day chart here pretty much shows what the beekeeping season looks like. And over here, the dotted line here is I tend to give pollen patties early to my bees, just to make sure that I get an extra round of brood prior to first pollen, so that I can actually go for the June nectar flow. Okay, so the reason I know that is I've collected data, and I'll go through why I've used some of the data to help me improve. And the June honey is the best honey because it's all native wildflowers up here. Okay, so I tend to feed fairly early to give me that head start. And the other thing it does is it helps me assess my queen at first inspection. Okay, so challenge in the Yukon is we're forage limited. So most yards, especially in the boreal area and in the outskirts where we don't have much sweet clover along the highway, we probably keep 2 to 4 hives maximum in one location if you want honey. You can keep more, but you'll just have to feed. So I have 3 yards, probably within 5 to 10 kilometers from the house here. And I keep 2 to 4 hives in each, and I overwinter maybe 10 colonies. I do a mix of different sizes, so I've successfully overwintered 5-frame nooks outside here, doubles and singles. And since my one bad winter where I had honeydew, I tend to lose maybe 1 colony to nosema late spring. I don't really lose colonies in winter, and it's always because of that attrition. The dying bees, because of nosema, the queen gets infected and they just can't recover. So I've got a mix of queens. Most of them are mutts. I do have some saskatraz, and just to make things easier, I use polystyrene hives, and it just reduces the amount of insulation. and it actually helps with brood building in spring. So just some mindsets. So especially for beginners, it's important that you be curious. And there's no one single reason why something happens in beekeeping. There's always multiple facets to our problems. So be curious, ask a lot of questions. And the other one is, it depends. So you need to be able to tolerate ambiguity. And the more you learn, the more you have to learn to be humble. Because it's not about being right or wrong. It's about growing ourselves and the people around us. The other one is perspectives. So I think this was a dragon eye view of the world initially, but I changed it to bee eye view of the world. And it's important to look at different perspectives and different directions. And that's the reason I like collecting data. It allows me to look at my bees from different perspectives. This is their current behavior. What it really means is hypotheticals. You want to minimize it. I like experimenting, trialing different things. So in this presentation, I'll go through my slatted racks where I've compared slatted rack, which is, I think I have a picture, versus non-slatted rack colonies overwintering. The reason I do Facebook and YouTube sometimes and got the B group going here in the Yukon was actually to share information and sort of grow a collective intelligence up here. And the reason I do these presentations and I create these PowerPoints and stuff like that is that's how I work. I need to put it down on paper to, I guess, to make it forces me to talk through my talking points. Because if you can't teach it, it means you don't know it good enough yet. So teaching helps you learn better. Okay, so why do monitoring? Main point is because beekeeping is local. So you do need information on your own area to grow and to understand why things happen in certain ways. Okay, because a lot of the feeding, pollen and sugar syrup and winter super and all these types of things have to do with some usually environmental cues in your location. Okay, so different things here. Again, pooling information, improving your yields, and understanding the bee stressors and the disease cycles. The thing with too much data is you'll get paralysis. And that's the danger with a new beekeeper. I don't recommend they get into monitoring until maybe 2-4 years into their beekeeping, because there's a lot to learn and too much data actually paralyzes you. Okay, so what I do is, and the other key thing with data is when you're collecting something, it has to be in relation to something else. Okay, so it's all good taking internal temperatures, and a lot of people they'll buy a temperature sensor because they want to know if their colony is alive in the winter. And I'm like, well, just wait till spring, or just put a stethoscope or just clean the entrance out and look for dead bees, and you'll know if it's live or not. So you don't need to spend the 30-50 bucks on a sensor to do that. Humidity, hive weight. A lot of folks, first thing I teach them is the hefting. Every time you visit a colony, heft it from the back, lift it, see how heavy that thing is. And the more you do it, especially you do it before you do inspection, so that when you go in, you'll actually see what weighs how much. So you'll see, oh, there's 3 frames of honey, there's this much brood, this is how much it weighs. And the more you do it, the more you'll learn those skills. I've got a weather station here, but understanding your weather cues, high progression, inspections early on, don't be shy about inspecting. Again, mite counts, nosema checks, visuals, there's all these things you can do. And I'd say we've got labs in Canada. I encourage people to send and talk to a biology teacher at high school and offer up a bunch of dead bees because they have microscopes there, and there's some really nice projects you could do with kids to help them learn about nature and bees and diseases and biology. So don't a lot of times you don't need to use big labs to get some diagnosis. The bloom dates. So unfortunately, my dog passed away after 17 years this year, but he was great because he forced us to have big dog walks, 5-10 kilometer dog walks almost every day. So while we're out there, I'm looking at the flowers. Being an engineer, but a lot of this is around HVAC, people who build houses. There's some information or interesting information just by calculating heat loss in a non-super technical way. Okay. The best monitoring tool for beginners is to basically taste your honey, listen to those hives. Does it smell funny? Touch and look. And for a lot of beekeepers, you go out to your colony, bring a camera, take some pictures, especially if you want people to help you. And the key is educate yourself on biology and behaviors. And this is by looking outside and seeing what's going on in the colony. And the more you do that, the more you'll clue in and the faster you'll learn. So for example, I run singles, I run doubles, I run whatever I need to be successful. So this here was actually adapted from some of Ian's videos, and a fellow up here who called up Ian and asked for some advice on running singles up in the Yukon. So I put a quick, this is how I manage my singles. But sometimes I'll run my doubles because I need doubles going into winter to be able to get that June honey, because I need that colony super strong really early to go get my June honey. So I've got two styles. My singles go for the July, August honey, and my doubles go for the June honey. And then I do splits to recover my losses if I have any. One big thing is this is how I access my colonies. This was mid-April last year, and I've taken these wood chips out because they don't really do anything, so I just put insulation in here, but I have a center slot here, so it allows me to pop the top out of the colony, not disturb the colony, and then this is where I put my my pollen patties. So it allows me to open the colony up without really disturbing it, shutting her down. And then some of these sentinel hives have sensors, and pretty much an hour to 2 hours after that pollen patty, the temperature spikes to 35. And it tells me the queen they're prepping the nest to start laying. And then usually my first inspection is about 21 days later. So I get to see freshly emerging bees, the eggs, the larvae, and it really lets me assess that queen to see how well she's doing. So I try to make sure I put my pollen patties about a month to 3 weeks or more before my first probable inspection. Sometimes it gets warm, so I put these bucket feeders out just to give the bees something to do, because they'll just go and die in the snow. So if I do this on my warm deck, they'll fly and they can fly back, and at least they'll fly back with some energy, and it helps that colony out. This is usually my first inspection. So sometimes I get lucky and I get an inspection in March, but pretty healthy clusters. Again, a mix of doubles and singles, and that's what I'm looking for. This was a 5-frame nook that overwintered. It overwintered really well, and that's the reason I want these. Is it helps me cover my losses or boost up a weaker colony if I have to, and bank some queens. Again, when you're inspecting, I take a lot of pictures. First inspection, check the brood, assess the queen, check for stores. If it's a weak colony in a double, I'll shrink it down to a single. I'll add pollen patties, and I'll keep it quick. And if I have dead outs before the bees get too active, I tend to sunbathe a lot of my frames I just spray peroxide on it. Does it work? Maybe, maybe not. But it helps dry them out and clean them out. And it just, being a hobby beekeeper, losing maybe one colony a winter out of 10, it's not too difficult for me to do that. First inspection, a lot of times the cluster gets shifted to one side or the other. I like to center my colonies. I might add some honey frames on either side. You'll notice that I write HHCBBBCCHE. So I write on the top of my frames, especially for the first couple of inspection, and then it helps me track. I'm terrible at note taking, so I just write on the frames. And what it does, for example, a week after, I think it was 2 weeks after I inspected again, the brood nest had grown into the C and into that C, so it actually had grown by 2 frames. So I was like, good. So this was check, this queen's doing well. So like Ian, I do probably 2-3 assessments before I make a call, but I usually requeen mid-May because I'll know already because of my early feeding pollen patties. First thing you need to learn as a beginner is diagnosing deadouts. They will happen. And I'll tell you right now, so if you read the Kappa winter loss report, a lot of beekeepers use weather, they'll use queen, they'll use mites, they'll use weak colony and all these things. And in my book and what I do is most of those are preventable to a certain extent. So it's up to us as a beekeeper to understand why our approach didn't work or why it was poor winter rep, and then come up with a solution. So this is an example of a cluster. It's a healthy looking cluster, but this was one of those high attrition nosema colonies, a bunch of dead bees in the front all winter. It lost most of its population. So what I had to do is pull this bottom box because it was actually bound, top box bound because of the frozen bottom box. So basically you pull it out and you do what you got to do. But now I've recognized that once I see these symptoms, chances are it won't make May. It might make it into June, but typically the queen is unhealthy and it just can't keep going. This here was my first experience with honeydew honey and severe dysentery. I've only had it once, but I'll talk about that honey in a bit. For those with screen bottom boards, Yukon's cold, so I keep them closed most of the summer, and I actually open them up in winter to help with moisture control. But in summer, what they do is I'll go clean them up probably the day before my inspection, and it tells me a lot about what's going on in the colony. So the progress, the hatching bees, in this case, there's some mummies, some chalk brood mummies. Every Varroa treatment that I do, I use OAV here with the odd formic acid. I always check efficiency of treatment because when I do washes, I always get 0. So I'll use an OAV to give me an idea of how many mites I have because it's pretty much doing the same thing. And then I'll retreat if there's a threshold. So if there's more than 15 mites on an OAV, I'll retreat. And if it's more than say 70, now I think I'm going to do Formic Pro just because I need to knock those mites down. Again, mites for me, it's usually the 3rd year of a colony that it's an issue. And before that, I could ignore it for 2 years. The 3rd year is where basically I'll get a PMS, so parasitic mite syndrome, and I'll get some issues with the brood because of the high mites. Again, field observations, when you're looking at your colonies, these are the things you need to notice. This one here was a nice centered brood nest. This one here, the brood nest was in the front. The capped honey was in the back. It was a weaker spring cluster. So then I moved it into a sunnier position so that it would get better sun exposure. Again, I'm always bushwhacking and doing stuff in the bush. So I always look for my bees. So this was a new nectar pollen source. It's like Marsh Fleaworth. There's some flooding that happened near the house. And this whole probably 10-15 acre area of these yellow, it's an aster family swamp flower, started blooming and my bees were all over it. Super happy. First time I tried mating a queen, creating my own queen, I noticed this in the yard on top of the colony. I was like, cool, I guess my queen got mated. And this is in August, and it's noticing my bees attacking fields of dead fireweed and actually collecting orange looking rust spores. So a lot of people, they see orange in fall and they think it's in late fall and they think it's pollen, but a lot of times it's actually rust spores. Okay. So lots of flowers, and most of our flowers here are native. We do have roadside clovers and stuff like that, but most of it is just native flowers. And one of our key nectar sources is actually willow, because our willows, they go from late April to early July. So I think most of my June honey is actually, there's a big component of willow in it. So these bloom calendars is just go out. Did you see a flower? Try to identify it, write it down. It's in bloom. Did you see a bee on it? If you saw a bee on it, what color pollen was on it? And that's how I did it for 3 years. I had my iPhone and I just take lots of pictures out in the field. And then I bought this $20 pollen collector at Amazon. And I collected, say, for 3 hours, 4 hours, and then weighed it, the color variety throughout the season. I do it every 2-3 weeks, and it just gave me an idea of pollen flows and volumes. So this one here, again, it's if our first frost is late August, or sorry, early August, and if I don't start feeding pollen patties typically at the beginning of August, the queen slows down her laying. So now if I just start feeding pollen patties, pretty much late July, first week of August, what it does, the queen keeps laying for another month and a half. And what it does is it reduces the age of my winter bees, because the first couple of years I didn't feed pollen patties and I'd had really, really small spring clusters. They'd make it through, but it would take me till July to get that colony up to strength. And now I get to split my colonies because of swarm control in May, which is great, late May. This again is just simple math. By me doing first patties in March versus natural pollen here. So if I don't do first patty here, it means that my bees are in the 300 to 250 day range, depending on when the last laying was. So you can see how just using a bit of math and because there's bees in the box and there is some winter brooding going on, but it's minimal. Again, these are all the things that make your bees die and not last as long as they could. So our job is to understand each of one of these and see what we can do to reduce it. So for me up in the Yukon, metabolic aging, so them generating heat to stay warm, cold stress, those are the first two that I dealt with my insulation. Varroa and stuff, if I do minimal treatment here, it keeps them under control. And Nosema is just one of those things that is there, and I'm trying to figure out what triggers it. So I'll get into a bit of microscopy. This one's a bit more complicated. It does take some practice, but this is where if there's a science lab at the high school and they're looking for projects, there's tons of stuff in nature that you can give them baggyfuls of dead bees to crush and to look for spores and investigate their gut contents and all that type of stuff. And I guess it could be interesting. So this is my honey project. I've got 54 honeys. I've got some from northern BC. I had the raw bee made as a control, a couple other ones, but most of them are from the Yukon. 3 from Quebec in the, I guess, north of the St. Lawrence in the boreal forest. For example, this circled honey here, when I had it tested, it had 50 grams of glucose and fructose per 100 grams, so 50%. So a typical, like not rapeseed, but canola honey or even a clover honey is in the 70 range, 70 grams per 100. So this is that year I had nosema and dysentery. Is this honey was pretty much full of stuff and lots of complicated sugars that are hard to break down and really low energy. So about a good 50% less energy than a typical honey. So it makes me understand why the bees struggle so much that winter. So the more you look at stuff in the microscope, the more you'll start seeing stuff. So for example, this is a low bush cranberry pollen, so lingonberry. It's in the honey, it's in different places. There's some dandelion. So these are things that you could do with your microscope. This is my current investigation is looking at nosema, but also the connection to this amoeba disease. And this is a picture. I've got 4 or 5 similar pictures, different years. So I usually have one colony that does this, is I have a pile of dead bees in front of that colony. And when I test these bees, I get high nosema. I didn't know about these amoeba disease, but now I'm starting to recognize these little balls here. I'd say I'm probably 75% sure it's that. I'm going to get some higher resolution pictures and send it to a lab to get it checked out, but size-wise, everything checks out. Again, after I saw the bees collecting rust spores, I grabbed the leaves off the fireweed, checked it in my microscope. It looked like this. I noticed these red things when I was checking these pollens under my microscope. I got this, so a bunch of rust spores and these winter, I guess, septa, so they're a type of spore, and they're associated with the rose family, so this here. So it's this is the bee gut, so you can see how there's resemblance. There's my honeydew honey. So you can see how there's connections between what the bees forage and sometimes what is potentially good or not good for the bees. And the reason I feed pollen patties is to minimize the amount of foraging of these rust spores, and also keep the queen laying. And I came up with my own little system of how many dead bees versus basically spore concentration. Okay, in the lab they'll do 1 million. They'll have these little counting slides, and it'll be very technical. I don't have time to do that, so I just keep it simple. I follow the exact same procedure, and then I just get a visual concentration of the nosema spores. And if I get this and that, a 5 and a 5 or a 5 and a 4, it usually spells that that colony is going to have issues in spring. It'll make it through the winter, but then it'll struggle, and I don't spend too much time on it. Because sometimes I'll have a lot of spores, but no dead bees. So it means that the odd dead bee did die of nosema, but there's no associated mortality with it. So this is from a couple days ago. Again, so a bunch of dead bees out front. I used to take a bunch of bees together and squish them in a bag, but now I just take 5 to 10 random bees and I squish them on a slide, add a bit of water to sort of soften it up, and you can see the nosema's full. And you can notice these little balls again, which I'm assuming, and I hope to get confirmed, are these amoeba spores. And there is a connection with, they call it a co-infection, but there hasn't been much research on it, so I'm just trying to figure that out. So most failures is like a Swiss cheese failure mode. I know I'm covering a lot of stuff here, and I apologize. My brain's full of bee stuff. So, and like I said, if you have questions, I don't mind answering questions offline to cover things in more depth. Okay, so in beekeeping, there's so many variables. So you got the age and the health of the bees. So when was the last pollen? Queen age. And there's research that shows that older queens will have, they're more prone to issues with nosema. So I tend to requeen after the second winter. Hive properties. So how many bees? So for example, my nosema issue only happens in my doubles, never happens in a single. So to me, the R value is the same. I only use bottom entrances, so ventilation is pretty much the same. So the only difference is volume, okay? And there's an energy number of bees per volume factor in there. So winter food quality, so again, honeydew, sugar syrup, honey, wet stores, and all those types of things. Water management, so dysentery, yes, it has to do with them eating things, but also managing water is part of them managing if they're full of water because they can't manage it. So dysentery is a potential issue. Like I said in the pre-conversation, this amoeba disease does affect, it's called the magpiegelin, I don't know how to pronounce it, but these tubules that are between they're attached to the outside of the mid and hindgut, and they act like the kidneys, and they do have a water regulation function. So to manage salts and nitrates in the bees. So pretty sure there's a connection there. So again, how many bees start off the winter with nosema and other stressors? So again, the challenge with YouTube is you got these people checking their colonies every week, checking for food stores. Okay, so I set up my bees and I don't touch them till I put that first pollen patty. It is what it is. If I didn't feed them properly, because every disturbance creates stress, and I think I'll have enough time to cover that. So I'm going to get into this heat stuff and temperature things. Okay, so there's so many factors, and our job as a beekeeper when you're learning is to try to understand how each one of these influences your success. Because if you get good wintering success, then spring and summer, it means you can sustain your apiary. I haven't bought bees in 5 years, 4 years now, 5 years, since I lost a bunch of colonies to that honeydew. And now I just make splits, make my own nooks, and I buy queens to supplement sometimes. So hive sensors. So there's no history in the Yukon with beekeeping. There's some old timers, but because we're so regional, so many microclimates. So the weight scales that I bought really helped me understand when the nectar flows are, or how weak some of the nectar flows are, okay? And how oftentimes there's actually nothing in the environment of substance for the bees to collect, okay? So luckily, my system now is way better and I've got bigger colony numbers. So I have a lot more foragers. So I don't tend to get these down dips anymore. So this black line here is actually the weight of the colony. Okay, so anytime that line goes up, it's nectar coming in. If it's going down, it's them consuming more than they're bringing in. And these little spikes up, it's me feeding them, a gallon of liquid. So by doing this, I got a really good understanding of when my nectar flows were. Okay, so on the temperature front, this here is a rabbit hole and there's so much you could do. I'm going to show you my wintering model. It's really complicated, but I'm going to cover some basics there. Okay, so this here it's in the Kappa Wintering Guide. I think Southwick and Seeley put it together. Southwick did the original research, and it just shows a basic curve here of ambient temperature to how much energy these bees are exerting to maintain their metabolic heat inside the colony, okay, or inside the cluster. The other thing you'll notice is how this curves up. Okay, so I have a feeling I understand this, okay, because at -10, that's where that cluster's at its tightest. And after that, they just generate more heat. But I'm going to show you a few things around humidity that probably this curve going up here is actually has to do with heat, but also with them needing more moisture to stay hydrated. because as the air cools down, regardless of the relative humidity, that air is super dry. Okay, so even at 90% humidity, the ratio of how much moisture in the air is tiny. So this was from 2 years ago, and the bottom two lines here, this is a double, this was a single, and it was just me calculating the heat loss out of my walls based on the outside temperature. So outside temperature versus inside, and it just gives me, because the problem with this chart here is they relate this metabolic rate to outside temperature. But once you start insulating your colonies, you've actually changed the environment. Just the waste heat coming off of that cluster is enough to actually heat the inside of that colony if it's insulated with managed top insulate or top entrances. So if you have 0 top entrances, all the heat staying in and it's slowly dissipating through the walls. The more top ventilation you have, the less of that waste heat the bees get to use. Okay, this yellow line here is a wooden colony, and it just shows this is pretty much our value. Okay, so in a wooden colony, pretty much the inside temperature equals the outside temperature. But in a wooden colony, or sorry, an insulated colony, that's not true. Okay, and then here, this is energy loss. And the reason why bees cluster, especially in a wooden, uninsulated wood colony, is basically this is not sustainable. Okay, so basically 45 watts of heat loss at -40. Okay, so even at 30 minus 30, it's 40 watts, which is just not sustainable. The bees would just starve to death and freeze in the long run. And you can see that my bees, or in an insulated colonies, it's in the 5 to 8 watts at -40, which is reasonable. So I apologize, I might go a bit over. So there's a few different concepts I wanted to relate to beekeeping. So a lot of things you read or see on the internet sometimes is they think bees are special. They are, but they can't defy the laws of physics or engineering. Okay, it is what it is. So there's something called the stack effect, the buoyancy. So it's like the hot air balloon. So you put hot air in a balloon, it'll go up. So if you put hot air in a bee colony and it's fully enclosed and you're not losing heat from the sidewalls, that hot air is going to get captured in that box regardless. Okay. If you put a top entrance, that hot air wants to rise. So it'll create a siphon. It'll actually push air out of that. It'll create an engine, a airflow engine. The other one is, this is actually, I didn't realize how much, but when it's protecting your top entrance, and I'm not against top entrances, is important to make sure that if it's on a windy day, you protect that entrance because the flow can reverse because the air pressure changes. Okay, and I'll just show you a quick thing there. Bernoulli effect is basically the bigger your top entrance is, the more flow through air you'll get through your colony. Okay, so in our colder climates, there's a beekeeper up here. He does top entrances. He manages a smaller, lower entrance, which is fine. And he does fine. He never loses colonies. His bees do really well. But the key thing is his top entrance is limited to, I think it's 5/8 of an inch diameter hole. So that is pretty much what controls the flow through. It throttles the airflow. The whole humidity heat thing. So there's psychometric processes, natural convection. There's single entrance versus double entrance, and natural convection is controlled by the difference between the inside and outside temperatures. Okay, heat transfer, there's basically conductive, so through a solid, convective, so it's the air heating and moving around because of different densities. And then radiation is just, we've all had radiant heaters where you just stand and you can feel the heat hit your hand or the energy of the sun heating the side of that colony. So we get all those inside the colony. And the challenge with these sugar boards or candy boards that a lot of people use is they'll use wood shims. And most of us who've built a house in the north understand thermal bridging, those 2x4s or 2x6s in the wall, how they conduct cold or pull cold air in or heat out. And those are usually the locations of mold and condensation. So what I've tried to do with my data is look at these concepts. Okay, so with a $30 sensor, I was able to get my annual bee cycle. So I repeated it at 3 different seasons. So red line here is the internal temperature above the brood box. This brown line here is the, whatchamacallit, outside temperature. You got your daylight here, and you can see brood rearing, so 35 degrees Celsius. Late August, it starts stopping. It flatlines at around 18, 20 degrees. And then after the solstice, it starts climbing up again. Some of this has to do with the cluster moving around. And now that I'm using singles, I get to see the cluster in a different way because there's less space. There's less open volume, and the bees are better able to manage that space. The thing around honey consumption, so I do get about this consumption per month, so about a pound a week. But the thing I don't get when it's well insulated is a lot of this 8 kg per month that's quoted is for a non-insulated colony, okay? Because the difference between this will go up by I get maybe 3 to 4 kilograms max in winter consumption, or sorry, in late winter consumption when brood rearing starts, versus what a lot of the papers and stuff quote. And that's just, I've linked it back to heat loss of the enclosure. So we've covered this already. So this is an example of my monitoring. Okay, so I've got a sensor on each corner in the center. So basically I've got 9 sensors laid out on this top of the cluster, one in the center. The center one usually measures humidity. And then I've got sensors below the cluster because that's the temperature that really tells me what the metabolic rate will be. And the thing I've noticed is the humidity inside at the center is actually the dew point, so the condensation area is actually equivalent to the inside edge or just the center of the estimated cluster. Okay, so what that tells me is the air is saturated on the outside edge of the cluster. So it's interesting because that's where the outer bees are, and it would allow them to consume that water and bring it back in. And you can see it's minus 22 outside here, but the coldest is what, 3 degrees, which is pretty good. And on the bottom board, it's minus 7. My sensor just below or on top of the, the slatted rack here failed, but it's usually about 8 degrees to 10 degrees higher than this bottom board because I've got 2 years worth of data measuring that. So I've got a formula to estimate it. And basically, yeah, so you can see how this colony is nice and cozy. This middle colony here is, I'm good at visualizing data. It's like the Matrix. If you watch the movie, you start seeing things. But I see a ball here. You can see, if you know that the center of the cluster is usually around 18 to 21 degrees Celsius, you can sort of see that there's a ball here, and this is a snapshot at exactly the same time. So you can see that this cluster here is actually more ball shaped, and this one here is more of a hemisphere shape. Okay, so they're clustering and closing on each other. And this is my control hive, and this is just on the side with some sensors, and it tells me what the temperature with 60 pounds of honey looks like at the same time. Okay, so the challenge is a lot of people put one sensor in their boxes, and then they wonder why the readings are all over the place. It's especially in a double. So if I had a double here, this cluster, a lot of times it disappears. Okay, even if you have 18 sensors in those boxes, my cluster disappears. It means that cluster is super tight. Okay, but in a single with a slatted rack, that cluster is nice and relaxed. It's still clustered, but it's able to actually heat that space if it has to. Okay, so this again is just a proof, me calculating heat losses. This was I got some data from the guy at Broodminder, Theo, for an equivalent setup. And his bees were just starting to get to brood rearing, but then it got to -3, oh no. And then it failed on brood rearing. So this was overnight. And then it struggled, and it took 3 nights before it was able to bring the temperature up to 35 to start their brood rearing. So you could see it was struggling. So from a heat loss perspective, it's about 4 pounds a week of heat loss. Okay, 36 watts. And this is equivalent setup. So I think it was -12 here. So you can see it's losing 2.8 watts. So it's consuming about equivalent 0.3 pounds of honey. The difference with outside is about 36 degrees. And then that day went up to 8. Nothing really changes other than it loses less heat because the outside temperature is less cold. And you can see how I've got sensors underneath. So over the last few years, I've been able to model the approximate shape of those clusters in my singles. This is one of those complicated ones. Just let me know if you want me to stop there. If you're happy, I'll just keep on going a bit. So you can see this is where, if there's any engineers in the room, you can get the spreadsheet if you want, but this is how I convert this data. And what I do is I've got, say in a typical winter, there's 3,000 hours of data. So I calculate this and I take a snapshot for every hour of the winter, okay, over time. And you can see I've got my outside temperatures, I've got my humidities, my energy consumption, the approximate shape of my clusters, how much energy they're using, how much sugar energy, so how much equivalent energy honey they're consuming, how much water they're generating, okay, because those are all known facts. Then I'm using this Southwick curve, using the temperature just below the cluster here versus the outside temperature, because this average temperature down here is what the cluster is really exposed to, okay, because the inside temperature is not equal to the outside temperature. So I'm able to get an idea of approximate metabolic rate for that colony. Because again, folks who don't insulate don't understand that the behavior of our clusters is different. Okay, and this is just data points from last year, and it was for the whole winter. And you can see that the gray is the center of the colony, all the data points, versus the outside temperature. So you can see it's around 20 degrees Celsius. Yellow is on the east side, and orange was on the west side. So that tells me that the bees favored the center east side of the colony most of the winter. And this light blue here is the temperature below the cluster. So what I'm able to do with all these data points and plug them into this, I'm able to generate this type of data on an hourly basis for the whole winter. And what it does is it allows me to create charts and get a better understanding of what happens when it goes from, say, -5 to -40 in 12 hours. How does the cluster react? Okay, so this is just an example of all the temperatures. So every point here, every value is 1 hour. Okay, so over here, for example, so -4 to -7 C, there was 500 hours last year during this period. Okay, the average was around -15. The extreme cold was -48. The challenge is most weather stations that don't cost a fortune, they stop at -40. But the interesting thing here is the temperature below the cluster, above the slatted rack, spent probably 90% of its time between 0 and 10 degrees C, which is wonderful. Because if you remember that metabolic curve, that's the sweet spot of lowest consumption. Okay, minimum temperature was between, the average majority was between 8 and 17, which is very respectable. And then this tells me that the bees like maintaining 20C in the center of their cluster. This is a complicated one, but I just wanted to show you an example of how I can convert this data into other images. So now I've got my predicted volumes of my cluster based on a hemisphere geometry. So for the different temperature gradients based on outside temperature. I'm probably confusing the hell out of a lot of you, but just this is not clustered. So very open cluster, and then this is where they cluster. So you can see as the temperature drops, they cluster, uncluster. And the key thing you can see from February is the 24-degree range is starting to increase. And then, oh, it's hotter. They still cluster, but it's warmer. And then I fed my pollen patties here, and you can see how the 30-degree range now, this brown, pops up. And this is the start of the brood. So the volume, predicted volume of the colony that's in the brood. Okay. So many things. Just so you know, my estimate, if I just do rough crunch, natural convection type thing, is I'm losing about 7 watts of heat out of my bottom entrance. Okay, and I'm losing 5 to 6 watts at -40 on my side walls, which is reasonable. My bees don't really cluster until -16 temperature outside, as shown by here, and I'm just building relationships based on outside temperatures. We always hear that bees don't heat their enclosure. Well, I've got data that shows differently. For example, it was -46. This was last year. This is what the cluster looked like. And no disturbances, no people. Out of the blue, so this is for this extreme one here. Basically, the bees just heat up the whole box for a few hours. And they do actually, this gray line here is the temperature. It's the average temperature. This is the temperature below the cluster. So this tells me they're actually heating the box. And there's probably multiple reasons there. There's probably to do with hydration. It would create condensation points along the sidewalls. So if they're thirsty, because that's a challenge at -40, is there's hardly any water in the air. So the only water is through their metabolic water. So if they're getting thirsty, they would have to do something like this to generate enough moisture for them to drink and hydrate themselves. That's a hypothesis. Outside temperatures. This yellow line is no slatted rack, and the orange line here is slatted rack, and how much estimated energy, metabolic energy they're using up. So you can see there's a difference here, and that's usually heat loss through the lower entrance or just some type of radiation loss. But you can see that the slatted rack is a lot more stable at colder temperatures. And the one without that extra slatted rack below it is a lot bumpier. So it tells me bumpiness, so even here, so metabolic rate bumpiness to me is thermal stress. That's cold stress. It's the bees having to adjust, create heat. It's expanding, crunching. It's stress on the bees. So I'm more and more convinced that the slatted racks, especially for my conditions, helps reduce the thermal stress on the bees. So using all these numbers, I can predict how much honey I'm losing via my enclosure, so via heat loss, and then via the metabolic rate. So this was as of the end of January. And yeah, it's about ballpark. So they consume anywhere from 35 to 40 pounds in a winter. And The thing with this SS caveat is right now it's assuming the same size cluster. The SS one is actually slightly smaller, so it's not as strong of a colony, but we'll see in spring what they look like. Again, condensation. So a lot of people buy IR cameras to see if their colonies are alive. I use it to see where my condensation points are or where I lose heat loss. Because all these bright spots, that's where condensation will occur inside the colony. Okay. If you do use these brood minders or whatever sensor, I've chopped these tabs off because these tabs suck in cold air, and that's where you can see the the mold here. So it's a mold point. Okay, so you just make sure you tape those seams and make sure that there's no infiltration of cold air inside the colony. I know I have a lot of stuff there. Let's see. I'm gonna sort of skip over these words, just gonna focus on the chart. Okay, so a psychrometric chart is what we use to calculate dew points as temperature changes and how much water we have in the air. Okay, so typically our colonies are in the 70 to 60% RRH, relative humidity, during the winter. So it just shows that when you're brood rearing, the bees are having to maintain this environment. Okay, when you're brood rearing, it's high energy, so a lot warmer and a lot moisture. So the risk here is condensation risk once the brood rearing starts is higher risk, especially if it gets cold. Okay, because if you cool down this line here and you go horizontal and you hit this line here, that's the temperature, that's the dew point temperature. This is just another example of the heating event, and there's lots of heating events where the cluster expands, contracts, and you can see there's crossover points where the wall temperature crosses over the dew point of the air in the middle of the colony. So that tells me that it's close to condensation point, so it means that there's water condensing out at these colder temperatures along the wall once the colony cools down. Okay, so they've heated the whole box and now they let it cool down, and now the side walls, it'll start condensing moisture just outside the cluster. So at really cold temperatures, like I said, the air is really, really dry. Just to put things in perspective, the air inside the cluster is this blue line. This gray line is the air outside. So the ratio of that air to this air, it's actually 80 times drier outside than it is inside that cluster. So it means the bees need to come up with that moisture somehow. And the way they do it is by upping their metabolic rate, because it's the only moisture or water they have access to. Because to consume honey, they need water. So they need to, there's a cycle going on there where they need to generate enough water to run things. And lastly, I guess here it just shows that the bees have no issue maintaining absolute humidity, which is a more engineering way of measuring water moisture, because it's not relative to temperature. It's just how much water. It's 12 grams of water per cubic meter in the air. And you can see regardless of the temperature and the outside humidity, the bees are able to maintain it pretty flat, which is great. Candy boards, the issue there is there's no thermal mass. Okay, so this gray line here is that control colony where there's no bees, just honey. And this blue line is the outside temperature. And you can see how if folks underfeed their bees in fall, there won't be enough honey. Putting sugar on top in our climate is not enough, because the bees need that honey to store heat and to push back that cold when it swings, when we get those crazy temperature swings, our honey is what keeps us, our bees, from being too stressed, because it releases heat and it gives the bees a chance to adjust to the changing outside temperatures. So the challenge I have with these candy boards is people think it's an emergency thing, but it's actually not good enough for our cold climate, because it means that the bees don't have thermal mass. They don't have that stored energy to help them with these temperature swings, which we get regardless of where you are in Canada. Okay, so practical application is a lot of times people will keep empty frames in their boxes, especially beginners. If they're empty, take them out and put pieces of styrofoam or wood in there, because it's just wasted space, and the bees have to, basically, they won't be able to maintain it. It's going to chill them, and it's just so cold. So it's better to reduce the volume than to leave an open volume. And the best thing to do is, if you got honey frames, put them on the outside. Start with your heaviest on the outside and work your way in. This just shows that a bottom entrance only works. Plenty of ventilation, the cold air comes out, or the air comes out, the moisture. I don't get plugged entrances, sometimes bees, but I usually leave my screen bottom board open, so they always have access to some air. I'll skip that one. This one here, again, this is the wind effect. So I think 3 kilometers or 3 miles, or sorry, meters per second is about 21 kilometers an hour. Will reverse the direction of flow in a hive. And this, I got this from Pedersen Apiaries in out of Saskatchewan, and they put these cardboard entrance protectors. And I think that's a really smart thing to do, especially in the prairies with all the blowing wind. If you have them outside, you need to protect those top entrances, because what's the impact of the flow reversing? Okay, it's going to mess up the cluster. This is my basic setup. I've got 2 wintering yards, and basically I just put my colonies together. I put my 5 frame nooks in the middle. I tape all the seams between them, and then I build an enclosure around it for north wind protection. And you can see my bottom board here, my stand has an open slot here. It gets covered with snow. Right now there's snow up to here, so there's no wind exposure, and there's an open cavity below the colonies where my screen bottom opens to. I do a lot of 9 frames in a 10 frame box, and I put these pine boards on the outside, because the challenge with polys is condensation. It just flows, but if I put wood, it helps absorb some of the excess condensation if it happens. I use these pieces of plywood to protect the bottom entrance from snow, to reduce the solar radiation, because I want a nice stable entrance. I don't want it to heat up when it's -20 outside, and then the surface temperature goes to 5, and then the bees think it's hot outside and they start flying. So this helps me protect that. And the other thing is, it ensures that all the dead bees land right in front of the specific colony. Almost done. So these top boxes here, so this is a double with a medium on top, and I put extra insulation on top of, inside a medium and top of my pollen patty feeder. So that way, that's how I get the R30-40 on top of my colonies. Okay, so I'm really big on heavy top insulation to push that heat down onto the bees, and to make it so they don't lose any heat and there's no risk of condensation on top. And what I do is I use my hive tool, pop the lid when it gets a bit warmer in March, put my pollen patty in the middle here, pop it back down, close her up, and I come back in 2 to 3 weeks. Just so you know, if I can winter a 5 frame nook in the Yukon outside, if it's the right volumes to be, that's the key. And I make a decision usually in August, early August, if I'm going to go as a double, a single, or a nook, depending on how big that colony is. And again, this is a skill beekeepers need to learn. It's a 5-frame nook can survive in the Yukon, okay? But it's the volume. Keep the volume to bee ratio. You want bees to be tight, and you want it to be basically, this box here has 6 good frames of honey, and the partials in the middle, and it got fed, so it's good. But you can see how any empty space I plug up either with wood inserts or protected styrofoam board, because I want to crunch that cluster down. Okay, I think that was about it. So this was just me reading a bunch of papers, my observations, and I tried to map out the whole health aspect of bees, the food, thermal mass aspect of bees, the whole insulation, ventilation, volume aspect of bees, and then connecting the dots between them and how, okay, dysentery, if there's dysentery, it increases the risk. It's a vector for nosema. Nosema is an energy robbing disease, so it makes them consume more because their gut is competing with spores. Extra consumption means more consumption, more moisture, smaller clusters, larger volume, more heat loss, and it's just a really complicated process, but it helps me. That's how my brain works. So then I can focus on certain areas to say, okay, well, how can I minimize the impact of some of these different things? Okay, and I guess I went to school for this stuff, so that's why I use my engineering to help me with my beekeeping. So I went over, and
That's
any
all.
questions?
That's quite all right, Etienne. It's a lot of material to cover, and you've gone through some great pains to have great detail, and really appreciate it, because it does paint um, a really interesting picture, your data and the environment that you're keeping bees in. One quick question that's kind of been nagging me a little bit, because I also run some of that ultra compressed polystyrene bee boxes. Mice love them, and I noticed that you've got that space that you use underneath the sort of that spacer that you have, that ventilated spacer underneath the bottom board. How are you going through like 50 pounds of mouse bait a year, or how do you control mice from using that as a winter residence?
So because there's screen bottom boards, so there's a mesh down there,
Yeah.
so it's protected, and they'll go in the cavity. The 1 yard's in a hay meadow,
Mm.
so there's a lot of field mice in that one, and they nest down there, but they don't go after the colony. I don't use mouse guards because our field mice here, there's no shrews, so they can't get through the entrance. So my entrances are about a 1/2 inch by 2 inch wide, 3 inch wide, and the mice can't get in there. But they'll keep my entrance clean of bees because they'll go and nibble at them, but they tend to not chew at the polystyrene. I'd say squirrels in summer are my biggest polystyrene issue.
Excellent. Okay, I'd like to take the opportunity for the people present. I'd like to open up the floor. If you've got a question for Etienne, can you please raise your hand and we will get to you? Or you can also type your question in chat as well. And then we'll ask you to unmute your mic and then you can ask your question. So we'll start off with Ian. You have a question?
Yeah, just a quick question. It appears like the bees are putting a lot of energy into creating heat, and you've shown that, and the insulation you're providing is retaining that heat, which is helping. But you also shown that the bees are putting a lot of energy into creating humidity within that cluster also. So are we providing a better, hope you can hear me because I have the washing machine going, but can you hear, or can we over ventilate a colony when we're preparing our nests? Like we're trying to ventilate our hives to remove moisture. Are we actually providing them a detriment by doing that? Or what's your take on the whole ventilation issue?
I think, like, for example, there's a beekeeper up here. He started at the same time as me. He uses, like I said, a 5/8 hole. He pretty much uses just a blue shell around it. He's got a little a notched top cover, and he does fine. So I think there's a balance, and I think you can especially in colder climates. So anytime you're below, because I find my bees struggle between -10 and actually -15 to -5 seems to be where they struggle with moisture management. In my setup, but I'd say too much, because you hear about their bees being thirsty all the time. I've never seen a thirsty bee. They'll go for water in spring. I think it has to do more with brood rearing or helping them debung their guts so they can cleanse properly. But I think they need moisture, and I'm able to maintain the 60 to 70%. They tend to like 65 to 70%, and it seems to do fine. And I know folks are like, they're adamant about keeping it in the 40, 50% range, but I think that's too low. Especially what happens is the colder it gets, when they have these polar vortexes and you hear about people losing their bees, it gets cold, but they're ventilating so much, so they're losing heat, but they're losing any moisture. So it's a hard equation, and it's something I started doing this year, is to look at the whole humidity thing. Because there's a fella in Massachusetts, that Vino Farm guy, he gave me his data, and I'm looking at it because he's ultra insulated for Massachusetts. But I've got a guy in Kentucky who gave me his data, and they have similar humidity levels and temperatures. And the one's insulated, lots of no ventilation. The other one is no insulation, lots of ventilation. And that Vino guy, his colony's flat. Humidity's flat. They're able to keep that 70% flat. But the Kentucky one, it's all over the place. And it's just, for me, it seems stressful. And for the folks, if you get 90% success rate consistently, or more than 75%, I'm like, keep doing what you're doing. You're right. I'm a perfectionist. I'm trying to get to 100. I hate losing bees. And I know, like, for example, I was getting condensation on the sidewall. So the reason I went to those wood inserts was to prevent my bees from getting soaked up and dying. I had high mortality on the sidewalls because the bees would probably get thirsty, go there, and then die. So what I did is I put those pine boards on the outside walls, and now the bees seem to not die on the sidewalls anymore. So it's lowered my attrition rate over winter. So I think there's a balance there. It's a hard question.
Like everything in beekeeping. Thanks, Etienne. John asked me to moderate for a second here. So Rob Young, I see you've got your hand up if you want to unmute and ask your question.
Thanks very much. I'm wondering if you could comment on what the insulating value of snow is. So for example, if your colonies are buried in snow, what kind of insulating property does that provide to the bees, and is it making up for the lack of sort of added insulation that you're providing? Thanks.
I'd say snow is a great insulator. I use it. I pile it on. The thing with the Yukon is we don't get many thaws, so the snow stays fluffy most of the winter. It's really hard snowmobiling here. But I'd say no, snow's great. And the reason I also like that open pocket in the bottom, especially with the snow around it, is it helps maintain a -5 degrees. So a lot of times the temperature below the snow is anywhere from -3 to -5, regardless of the temperature above. So that's the difference, is your snow is going to give you that buffer. So if it's -20 outside and you got snow piled around your colony, basically you're going to buffer it down to -5. And That's why winter survival in the Arctic here, we build snow huts. We don't do lean-tos because you freeze your bum off. So yeah, snow is great. And I'd say if you've got it, use it. And no.
Yeah, I've seen some
Thanks.
pretty good examples of the advantages of being buried in snow. So I fully agree with what you're saying there. Etienne, I was very interested in your data on the slatted racks. My first year of beekeeping, I haven't been keeping very long, maybe 7 years. I wintered outdoors and I had excellent success. I've wintered indoors every year since, but I've thought recently that I want to start toying with outdoors. It's a little more interesting, as you've proven, and just different advantages. And slatted rack is one of the things that I've thought, you know, if I'm going to toy with that, I should probably work with that. So, I mean, can you give me some real practical, you know, do's and don'ts, or I've seen the data that you brought up, which was great. And by the way, I love the data approach. So many things we do and see people do and are advised to do are feel good. I feel this, and I do this for my bees because it makes me feel good, or because of, you know, this is what my grandfather did and my father did, and we've done it for, you know, 100 years, and so this is the way we do it. So I really love the data approach. So yeah, can you advise me on slatted racks? Really?
So on the slatted rack, I tend to take them out after my first spring inspection, and I clean them up. Okay, the challenge with polystyrene hives is we don't get the solar gain. We don't get solar radiation. So in a double, there's a lot of volume there below the cluster of empty space that the bees just aren't able to heat up. And the sun, I didn't have any pictures of solar heat and the impact of how it actually heats the box. So what I do is I shrink it down, especially if the cluster is not filling 2 boxes. And I pull my slatted rack out of pretty much all my colonies, and I'll clean them up and torch them and all that. And it's basically because I want them closer to the entrance so they can cleanse and do what they have to do and start foraging. Because I find that in my cold climate, it actually becomes a barrier. Okay, if it's in a wooden colony with solar gain, probably not an issue, especially in the spring. But in the winter, what it does is it actually reduces the surface exposure by about 58%. Okay, because if you take the racks and you take the outside area versus a slatted rack and the open area, it's 58% less open space underneath the cluster. Okay, and those bars are like, they create drag and they slow down the air movement, and that's the advantage of it. So there's that. The other thing I really like about them is by May, they're back in. Okay, but once the temperatures get warm and the colonies have recovered from winter and they're starting to ramp up, I'll put them back in because it helps me with swarming. Because in a double, they'll actually, for some reason, they don't put swarm cells like above a slatted rack. They'll only put them in the top box.
Well, that's interesting.
Again, there's always exception to the rules.
Yeah.
But I'd say 90% of the time my swarm cells are always in the top box, which is awesome.
Wow.
Because it helps. I don't bother looking at the bottom box until probably June. Once I start moving honey frames down to get it ready, because I move my honey frames down to the side of the bottom box from June. And it just makes the whole, and then I push down cap brood into the bottom box, because the slatted rack, again, it creates that nice warm spell, so they're able to keep it warm. So I move my cap brood down there, I keep open brood and build my frames on top, and it just helps me with my cycling when I do doubles. And with singles, it just gives them that extra space. because again, in a poly, they don't really beard. But for folks with, it's the bearding space. It just gives bees a place to step out, because
Yeah.
there's still about 3 inches there, 2 to 3 inches below the bars to the bottom board for the bees to sort of fill instead of bearding outside.
I'm using wooden boxes, and for wintering, I was considering I would just make a poly shell for it, perhaps, I don't know, probably 2 inches for that. So you're really only going without slatted rack for April, and with the wooden box with the shell off, then I might not have that requirement to take it out for that time, because I'd have that solar gain.
Again, it's all on volume, how many bees. If there's a lot of bees and they're foraging and they're flying
Yeah.
in and out, you can see it. I just see that they're not retarded, but they're slowed down.
Yeah,
That's
suppressed.
the word I was suppressed.
Yeah.
So, and that's the only time I take it out.
Retarded in a musical sense.
From the slowing down sense.
Yeah,
So the class 3 air brakes version.
Yeah, that's right. Well, thank you for that. I'll pass it back over to you, John. I see you're back.
Yeah, thank you. Just going down the list, anyone else have any questions for Etienne? Just raise your hand. Waldemar, just need you to unmute.
Hello.
Hey, yeah, hear you loud and clear.
Okay. First question is, with all the data that you collected and being here since 95 in Canada, I know that every winter, every spring, and every summer is different. If you extrapolate the numbers that you have, are they applicable across, or are they varying very much?
I guess you can see how I tried to relate things to an ambient temperature.
Yep.
And then some of the charts are based on calendar dates and times below. So for example, last year we had snow on the ground till mid-May. And it was really cold. I think we had minus 30 something. April, after I did that inspection, the next night it dropped to minus 30 something. So I'd say in general, the starts, but what I'm trying to do is to relate it to an ambient temperature, or relate it to a fixed value versus, so once the temperatures hit that range, I put my pollen patty on in mid-March. Pretty much regardless of outside temperature, the bees will produce brood. And so I try to normalize it so I don't put in those other factors. Does that make sense?
You're going more by the calendar than the actual occurrence of the weather pattern itself.
Because
I understand you're linking it to the ambient temperature, but still, if you know that you're having a bloom in June, and then you need to actually put your pollen patty in early enough in order to create the population, so you actually have that nectar flow being collected.
So yeah, it's always plus minus a couple of weeks. So last year I didn't put my pollen patty till April 1st, April 2nd. The year before I did March 15th. And the reason I did that is just looking outside, I knew winter is going to be here much longer. So I still look at outside. So if the snow is gone by mid-March, but we're still getting cold temperatures, the odds are the first willows will be out by mid-April. And if there's still snow on the ground by pretty much by mid-March into April, then I just push it off by a couple of weeks. So I do use snow cues, I guess, winter cues or spring cues to help me determine that.
Next question would be, how much is your R value overall after you actually wrap everything up? including the R values of the polystyrene boxes?
So I didn't talk about it, but the front of my colonies have about let's see, R9. So it's not that extreme. And the side walls and then hugging together might be R20. And the top is R40. And the reason my front has less R value is because that's where I want the condensation to happen. So I'm actually planning, so the wall with the lowest R value is where condensation will happen. And sometimes I might insulate the top of that front wall and leave the bottom uninsulated. So what that does is that'll be the cold point, and that's where the water is going to condense out if it condenses out. Because at -40, and we get them every winter, it's going to there'll be condensation in the colony regardless. So I want to make sure it condenses where I want it to condense. If that makes sense.
Yeah. One more question. The queens that you're using, you mentioned Saskatchewan. What else of your stock is there? What do you where else are you using?
So I bind, like my original stock were just nooks and mutts from the Fraser Valley in BC. And then some of them were really good. So I moved them into my 1 yard, and I don't know, I've raised 10 queens. So it's not big numbers because I don't need that many, but I've never had a queen not mate. And I usually keep 2 genetics in each yard. So it's only 2 to 3 colonies. I move a nook in there, and I've got one that's 4 years old and she's still laying like crazy. So it's, I guess, healthy drones. And then Saskatchewan, I try to bring different genetics every year, bring 2, 3 new queens, 4 queens every year, just to mix things up.
The reason I'm just asking because different races of bees behave completely differently through the winter time. So your data might be varying with some of the genetics too. Once you actually will have something that is not exactly a mutt, what you call, I mean, across Canada, we barely have actually clean races here anyway. So
I'd say predominantly,
answers, yeah.
I'd say predominantly carniolans, like dark black queens.
Anything else, Waldemar? You're good. Kay, you've got your hand raised.
Yeah, it's my wife's computer, so
Okay. I was saying you're looking prettier than usual. Go ahead.
Thanks. I was just wondering, it's a little off your topic, but how big of a problem are the varroa mites where you are? Like, do you have that many bees around you for cross infestation? I would think you'd be kind of remote.
I'm super lucky. I've got no other beekeepers within range, and literally, if I treat OAV, like I don't use packages. If I do, like I said, if I do a nook and I treat it right away on install, it's usually, if I do nothing, I'm good for 3 years. If I treat, I've experimented to see how long I could go without with getting away, but if I do minimal treatment every year, mites aren't an issue. But if I deal with them with 1 treatment, usually in the spring, or 2 treatments, then it's usually okay.
That would be awesome.
So when you're monitoring, you still put considerable effort into monitoring, do you not? Or
so because like I said, I do washes, or I did washes, and I've got the kit, and I tried for probably 3 years where I'd wash, but I'd always have 0 or 1 mite. So it told me I have low numbers, but I wanted to get another way. So what I did is I just treated with OAV, and I put my debris boards, and then I would count 24 hours, 48 hours, 72 hours to see what the drop is, and they would give me a number. And then I found a calculator online where somebody had done some research on using an OAV drop as a mite level indicator. So, and that's what I do, is because my washes were always close to zero, but I knew I had mites.
Mhm.
But if I do a wash, I get zero, I'd run an OAV, I'd get 20 mites.
Yeah.
The challenge is sometimes I'll do one early May or in April, but all the mites in that first brood cycle, they're all under cappings. So I'll get like a drop of 3 or 0 mites on an OAV, and I'm all happy. But then I'll do another one 2 weeks later,
Yeah,
and it'll
they're
go
all,
up to 75.
yeah, because they're all in the chamber, so to speak. Yeah.
Exactly.
Yeah.
So those are the ones that scare me.
Any other questions? I know a lot of material was covered and it's a lot to absorb. I really appreciate you sharing the Google link, Google Doc link for all of your charts and graphs. We're going to, I've posted it in chat a couple of times, and anyone else can email me for that link as well. We, especially when reviewing this presentation, there'll be very handy reference. And as well, if anyone has any questions, you're very generous in allowing our members to send you an email to clarify a point or to help interpret some data that they, might be a little bit, I know some of it's going to be quite over my head. So that's very kind of you. Very, very kind
No
of you.
problem. Thanks again.
No problem at all. Our pleasure. And thank you so much for taking the time out of your day. And again, a big thank you to the MBA for arranging you to be here. Can't thank them enough. And again, thank you really much appreciated.
Thank you.